Hi, I'm Dr. Beal, and this is in the first chapter of the textbook we're going to use in the first set of lectures. I have 2 lectures as a part of this chapter. You're doing them during Module 1, so you should have already watched the welcome video, which was introducing you to the class, showing you how to use Canvas. The rest of Module 1 is very much learning about how the Canvas site works and what your weekly expectations are. You do have a discussion post due this week. That is really an introduction to yourself and an introduction to you to the rest of the class. We're really doing that so I'm sure that you are comfortable with using the discussion boards. There is also a quiz this week. That quiz is all about you learning how to use the quiz and making sure that your equipment works in the way that you think it works. So go ahead and do those. And then this is starting the actual material in the class. This goes along sort of with Chapter 1 of the Cengage textbook. You should be able to access the online resources from the textbook as well as the text itself by clicking on Cengage on the side of the modules in Canvas. If you are having any trouble with any of this, please email me. This is my email. Or you can reach out to me through Canvas and we will talk about how to fix it, because this is the time to figure out if something is going wrong. I also want to make sure that you're ordering your kit for the lab this week. There is another video that is going to show you what's in the kit. So when you get it, you can go through, if you're a visual learner, you can go along with me and look at the equipment. But you need to do the ordering this week because it may take a little while for that kit order to go through. And by week 3, we really do need that equipment in that box to do the labs. This video today is introducing some of the big concepts we're going to take out through the whole class and keep tying back to. So today's lecture is really, really broad. I don't want you to get super overwhelmed with all of these concepts I'm introducing, because we're going to talk about them in a lot of depth as we go forward. We're just introducing some key ideas that you're going to need over the course of the next 13 weeks. So the way I'm going to do this, and I'll do every single set of videos, is I'll start out with a list of things that I expect you to take home from this video, and well, you're probably home, but take in from this video and apply in exams and quizzes and in your writings and in your discussions. I will always start out with the big ideas. For each video, I'll have highlighted in bold what I am going to cover in that particular video. So right now, as I'm making this, I think I'm going to have 2 different videos. My first video is going to cover 1, 2, 3 here. When you're studying for the exam and you're trying to synthesize the information, this is where I want you to focus. We do have a textbook, but all of the exam questions and quiz questions that I ask you about are going to be coming from these lectures. If you find additional stuff in the textbook, it's interesting and it is relevant and you can use it in your discussions and your paper, but I'm not going to ask you to specifically answer those questions. I'm going to get started. I am going to have on each slide, I have the concept, chapter concept we are underneath. So we're doing Chapter 1. The first part of Chapter 1 is the principles of sustainability. I try to keep my lectures linked to the textbook in case you're following along in the text. I will also always have key vocab words highlighted in red. So environment here is highlighted in red and bolded. That means I want you to know how to define that word, and I want to basically be able to use it in a sentence and you understand what it means in the way I think you do. I think that the environment is all living and non-living things that are interacting. So it's basically everything on Earth. So it's a very broad term. This class is really focused on the idea of environmental science, which is now the study of all of the connections between everything living and not living. It covers how does the Earth work, and we're going to do things like geology. We're going to talk about soils. We're going to talk about the way that the winds move. We're going to talk about how humans interact with our environment. How do we affect the resources that we actually use? What are some interactions that we have with things like the soil and the wind, and also the other animals on the planet? What about the energy cycles that move energy through our entire living system? And then how do humans interact with that? And finally, our overreaching idea, and this is what we're really focusing on today and we'll build on it, is if we live on a planet and we have to use resources, how do we use those resources in a way that is sustainable? Sustainable means that I can use them now, but they will also be available for future generations. How do I use a resource without using it up? We're really kind of focusing around environmental science in this class, but we have a lot of tie-ins to ecology. Ecology is a branch of biology that focuses on how living things interact with the environment. Environmental science is a little bit broader. It encompasses ecology and then all of those other cycles and systems that may be not involving living things at all, but impact us. We're going to look at the world as a series of ecosystems, a set of organisms interacting with the environment around them, things like the desert ecosystem, the rainforest ecosystem. I have a particular focus and interest on New Jersey. My research for my PhD was very much focused on urban ecology and how birds and insects and trees interact to create a diverse series of habitats, places where things live, and also how we can improve that for people and for the animals and for the plants and for the planet in general. I'm particularly interested in looking at urban systems, and so I have a couple times where I'm really going to focus on the ecosystems of New Jersey. I think you live in New Jersey. You may not, actually, because you're taking this online. But I'm going to look at different areas in New Jersey, and particularly around Camden County, so that if you have time to go out and look at some of these places, even though our class won't go as a group, you'll have a chance to look at some local things and see what I'm talking about in your everyday world. All of these words are vocab words I need to be able to use in the course. They are things that I might ask you on an exam. It might say, define ecology. And then you're going to have to say ecology is a type of biology that focuses on living things in their environment. When I highlight them in red and bold, this is a word you need to know. I will try to use those words in connections, right? You don't learn words in isolation. I will try to always tie them together in a story for you or to other vocabulary words, and that'll give you a chance to frame them in context. Sustainability is one of those things that we are going to talk about throughout the entire course. Sustainability is the end goal of what we're talking about. The sustainability is really how do we make sure to live in our environment and within our natural system and make sure that all those systems flourish, that they can continue indefinitely, and indefinitely means forever as far as we're concerned. In your textbook, they have little leaves, green leaves, next to concepts that come back to sustainability. Every time you see that green leaf in the text, it's saying, hey, remember one of these three, and I have a few more later. Remember some of these concepts of sustainability. This is something that directly applies to them. So there's three scientific principles of sustainability that have to do with biology or physics or chemistry. One of them is the fact that every living thing on Earth depends on the sun to get our energy. We're going to talk about how the energy moves from the sun into our living systems, but that is, for almost every living thing, the only source of energy that is coming from outside of our system. You get your energy from eating plants or animals, but if you get your energy from plants or animals, those plants or animals got them from plants that got the energy from plants taking the sunlight and converting it into a form that we can use. Our energy comes from the sun. Our world is very complex and has a lot of complicated living things that interact with each other. That is biodiversity. Bio is life. Diversity is diversity. It's complexity and having a lot of different things that go together. The biodiversity, we want to keep it as biodiverse, as complex as possible. And that actually in biology and in ecology and in environmental science, that complexity actually leads to stability. A complex environment is a stable environment in biology. And we're also going to talk about the fact that whereas energy flows, from the sun through living systems, nutrients and chemicals cycle. There is only a certain amount of nitrogen, there's only a certain amount of carbon, of oxygen. I'll say there is a finite amount. Finite is the opposite of infinite. It means that there is a measurable end to those things like carbon and hydrogen and oxygen. And we only have so much of each on planet Earth. The way that we all have access forever and all time is all of those things, all of that matter, all of the elements on the periodic table cycle through living systems, and they get used and recycled and reused. But the water that you drink is water that has been on planet Earth for a really long time. That water may have been part of drinks that your grandparents were drinking. It may have been rain that fell on the Paleolithic animals that lived millions of years ago. That may have been the same rain that filled up the oceans at the beginning of the formation of the oceans on Earth. Those water molecules have been cycling around Earth since Earth solidified. And that means that we have to figure out ways to reuse them wisely and keep them cycling into that system. Earth systems. There are 3 additional sort of non-scientific principles of sustainability. This is much more about how we act in a sustainable way in order to keep our Earth working for us in the future and for all the other biodiverse creatures on planet Earth. The idea of full cost pricing, I didn't make this red yet. It shows up later in other lectures as a vocabulary word. This is about economics. And then if we use resources, if they are priced in a way that reflects the actual cost, we are more aware of the damage we are doing to the planet, but also the value of everything we are taking in. If you full cost price gasoline or full cost price the cost of energy coming into your house, you would you would be paying more, but you'd be paying for all of the possible development of those processes, the impact it has on the environment. Full cost pricing actually often causes people to be more aware of the way they use things. Win-win solutions. This comes from political science, and it's a way of looking for solutions where the number of people that benefit is as high as possible. So we don't just have 1 or 2 winners and a whole lot of losers, which is a different type of political science. We try to make sure that the greatest amount of good per people is done with our choices. And then ultimately, and I've kind of already mentioned this, we have a responsibility to future generations. We have an ethical responsibility to make sure that the great-great-grandchildren that we are literally never going to meet, probably, are going to have the same sort of resource availability and maybe even better lives than what we have today. And so these 3 are things we're also going to come talk about in the class, the scientific side, but also the economic, political science, and ethical sides of the idea of how we live on a really complicated planet with a lot of people and a lot of other organisms and keep everything working in a way that the greatest number of living things win. It's a win-win situation. Some big ideas that we have to frame how we think about the world, and this feels very economics, and it frankly is. The things around us, the world that surrounds us is all the natural resources. And resources by definition are things that we need to use. The material and the energy that we get are resources. They are natural resources. They are provided by nature. These are part of our natural capital. What is actually out there, the environmental services that we have available to us and that are being provided by the environment around us. The ecosystem services are things that you may or may not be aware of, but the fact that we live on a planet that is very complex means some of that complexity is taking care of our everyday actual needs. Things like, and this diagram, I hope it's big enough for you to see, the ecosystem services are in orange here. Things like the ozone layer protecting us from UV radiation from the sun, the fact that the soil will renew itself over time if we use it sustainably and take care of it, The fact that nitrogen and oxygen and carbon are available to us in things like sugar and proteins that we actually need, that's actually provided to us by the systems already in place in the natural world. And we might work with it, we might farm them or make them more available to us, but those are still coming from the environment. They're still part of our natural capital. And our capital includes the resources and services that the world around us provides. Again, a resource is anything you need to live. It could be water. I think my head's over a little bit of this, but this is a cup of water. It could be food. It could be space. It could be clean air. It could be anything that you need to live or to live your life the way you want to live. What happens if you don't have enough resources? And who is most likely, if you think about all the people on planet Earth, who is least likely to get the resources they need? Who's the one that's going to end up with not enough clean water? Is it the rich people? Is it the poor people? Is it people in environments where they have a lot of natural capital available to them just outside, in the middle of a place where the resources are abundant? Or are people in places where the resources are not abundant or they're not as easy to get at? Natural resources are provided by nature. I know we kind of defined this already. I'm going to define some things about them underneath. Notice that natural resources is in red. It's a vocab word that I want to ask you about. I actually think you could probably define it before you take the class. So I want to branch out on that. I want to talk about the way we talk about and use resources. Some resources are functionally infinite. In anything we can imagine that humans can do, we're not going to run out of them. The sun is probably infinite, and as far as we're concerned, it is. There is sunlight that should be shining on planet Earth long after we're all gone. The sun is going to be around making sunlight. It is inexhaustible. We call that a perpetual resource. Compare it to something like renewable resources. Renewable resources like the soil, or let's say water. These are things that we can use infinitely if we use them responsibly. There are ways to use them up. So they are going to renew and repair themselves as long as we don't push them over a tipping point where they get used up faster than they can replenish themselves. These are called renewable resources. Things like wind energy actually falls in here. We'll talk about it. It's a little weird. You think the wind would be infinite, but we can actually, there's been a couple really interesting experiments where we could use up the wind. It would take a lot of work though. Non-renewable or exhaustible resources are ones that do not repair themselves. If you use some, it's gone forever. Things like iron. There's only so much iron on Earth. Helium's one that comes up a lot. We use them to fill balloons and make our voices squeaky, but we only have a certain amount of helium on planet Earth, and if you use it up, it's not available. Things like fossil fuels are probably more in your thinking about what is and is not available. Fossil fuels are, once we use them up, there's only a finite amount, and the situation that caused the creation of the fossil fuels is not going to occur again. Not in the lifespan of humanity. These systems that the ecosystem provides us, these are natural systems that are making the environment healthy and frankly livable for us. The environment cleans the air for us, it cleans the water, it protects us from UV radiation. We tend to divide ecosystem services into 3 different concepts. Services that provide provisions for us, water or food, biomass, which is a way of getting energy from biomass fuels, energy from plants that we can use to power cars, regulating services. Those are ecosystem services where it regulates the environment for us. we might be able to do some of this, like protect the coast with machines that we build or barriers that we build. But if we don't cause damage to the coast itself, it should ultimately repair itself. Now, whether it repairs itself and keeps all the houses, that's a whole other question. But it will repair itself. And cultural services? Cultural services are things like when you go out in nature, you feel a little bit better. You may have heritage and spiritual connections to the natural world. Those things are being provided by the natural world for you, and they're supporting culture and physical well-being and health. Humans have a really inordinate impact on planet Earth. We have about 8.2 billion people right now on planet Earth, and life has improved remarkably for those people. We are one of those people. For us people in the last 200 years. This chart, I pulled this off of ourworldindata.org. If you are looking for data about the world or different countries or big population level data, this is a marvelous website to start with. They collect data from censuses and all kinds of data collection services and kind of synthesize that data into readable charts and connect you to the background research for it. Our World in Data is updated right now to about 2023. If you look at, this is education worldwide since 1820. I don't have an axis here. It's just, let's say 100% at the top and 0% at the bottom. In 1820, a very small percentage of people were actually literate. And literate means reading at a 6th grade level or above. Today, in 2023, and this is worldwide, almost 91% of people are actually able to read at a 6th grade level. That's amazing. That jump in literacy means it's easy for people to share ideas and concepts. It's a huge reason for the improvement of the quality of life for people all over the world. And the quality of life has increased unbelievably even in the last 50 years, let alone the last 100. And I am aware that last 50 years means that I'm talking about the 1970s. It's easy to forget that, for me anyway. Lifespans have increased. People live longer. They have a longer span where they are healthy while they are alive. They're better educated. Way fewer people live in poverty than they did in 1820, let alone even 1950. People are living at a much higher quality of life. They have access to better foods. They have access to better nutrition. They have access to better water quality. Even the fact that our water and our air has become less and less polluted. We will talk about, there is times in living memory, maybe not your living memory, but by the 1950s, 60s, 70s, and 80s, even into the 90s, there was water pollution and air pollution that would shock you today in the United States, and let alone New Jersey. And we're going to look at some places that are very, very close to home that were too polluted to do things like swim or enjoy or breathe. And those places have been really cleaned up. Our world is a cleaner, healthier place. But our lifestyle is really unsustainable. So a lot of those improvements have been made at the cost of using resources faster than they can replenish themselves. We have degraded the environment. We have degraded our natural capital. And degraded means we have broken it down so that it's either not available to us anymore, or it's not in a healthy state anymore. 83%, excluding Antarctica, so we're not even talking about the Antarctic restation, 83% of the land on Earth is impacted by humans. And that could be humans live there, or humans have turned it into an asphalt urban environment. Renewable forests are shrinking. The atmosphere in the lower atmosphere is warming up. We're getting more and more drastic changes in the weather. Today I am sitting here after a week of digging out of the snow, and it is still here. This is the weather causing the snow to be here. But you know that the environment has been more and more experiencing extremes. So the last 20 years, almost every year, summer in the last 20 years has been the hottest summer in record. That's something that we have to deal with, and an impact of partially the fact that we've improved life so much and used so many resources to do that. The coral reefs are collapsing, the sea level is rising. I don't want to leave you here when you walk away from this chapter or this class thinking the world is ending. I want to boot back for 1 second. We are getting good at making life better for people. We just now have to deal with the fact that it's a lot harder than we thought to make life wonderful for everybody, or at least okay for everybody, and then not damage everything else around us. So I'm going to take you can pause me. I'm not going to sit here for 5 minutes in silence. That would be weird because I'm a video. But I'd like you to think about what are some of the environmental challenges that you are interested in that people are causing today. And I think you're taking this class because you're interested in these topics. So I think you might be able to come up with 3 or more. I got some pictures here if you need some hints. What I'm going to ask you to do is pause me. I don't have any way as part of this system to pause and have you type an answer in, but I'm going to have you do this as a thought exercise. Pause me, and then I'll hold silent for a minute, and I'll tell you when I'm coming back. Okay, I'm coming back. I think you have unpaused me at this point, and you're going to have a couple ideas about the environmental challenges to people. As part of this class, you're going to do some position papers talking about environmental problems or environmental wins. It can be either way. I think you may have picked some of these. I actually pulled these off of earth.org. They have a really nice layout and I did not pick all of them. I picked the ones we're going to talk about this semester. But I picked some of the things that humans are doing to Earth that we need to be aware of. We don't necessarily know how to fix all of this. But the first step to solving any problem is being aware of the problem. Things like the overabundance of plastics. We're going to do a landfill. We're going to do some soils and talk about some landfill structures of how we take plastics and we dispose of it. But when we do those plastics disposal, do they really break down? We do waste a lot of food. When we do that, we live our lives in a way that impacts the forest. Impacting the forest cuts down on biodiversity. Think about the loss of the rainforest. Changes in the carbon dioxide levels and greenhouse gases causes widespread climate change over time, which leads to the melting ice caps. Ocean acidification, the fact that the oceans are becoming a little bit more acid is degrading the coral reefs. The world is not ending. I do not want you to think that. The planet Earth has been around for 4.2 billion years and it will continue long after this. The question is it going to continue in a way that we live in and it makes us happy and we have a complex, stable system, or are we going to have more and more problems as we go along? And I don't have an answer for you, but I do have a lot of exploration and theory about it and a little bit of applications of how we do something. That's the whole point of this class. The first homework that is real, the first discussion that is a real discussion idea is I'm going to have you, so not the introduction one, but the one for the second week of class. I'm going to have you read a 6-page paper called The Tragedy of the Commons. And then you're also going to read a 4 or 5, I can't remember, 5-page textbook section. I've linked a different textbook for you. It's free. You just open it online. There's a PDF available that talks about the tragedy of the commons. This is something we will come back to a lot. Garrett Hardin wrote his paper in the 1960s about the tragedy of the commons and how people tend to overuse a resource just a little bit each time, and that degrades the resources over the course of years and years. I don't want to spoil it for you. You may have read it already, but I don't want to spoil the commons discussion for you. But I want you to think about, how do we manage a commons? What is a commons? How do we do this so that it is a win-win? A win-win is when the most people actually benefit from our solution. And I want you to really think about, as you read it, do you agree with Hardin's assessments? Are we only able to regulate with technical solutions? Do we need government to control absolutely everything? Keep in the back of your mind, Hardin was writing his papers in the 1960s when the Cold War in I guess the whole world, but the Cold War was really very something at the forefront of people's minds, particularly in the US. He was talking about, in some parts of his discussion, the nuclear arms race where people were accumulating more and more nuclear weapons. Do you think his fears and understandings about how the world worked 60 years ago are still applicable today? And so we will come to this in the discussion, but I would like you to think about the tragedy of the commons. And then as you read that, think about how we measure our impact on planet Earth. We have two big ways we're going to measure our impact overall of how generic people impact the world. One of them is your ecological footprint. The ecological footprint is a measure of your impact on the environment, and it takes into account how you get to work, the infrastructure of where you live, so the highways, the electricity, the way you get water to your house, the construction in general of the area around your house, how you obtain resources like building materials as well as renewable and non-renewable resources, how much food are you actually eating, and what types of food they are. It's a lot of metrics that come in and fit into your ecological footprint. Later in the class, sort of halfway through, I'm going to have you calculate your ecological footprint and think about your impact regionally on New Jersey and why it's going to be very high. Why is it so high? And then what is at all practical for you to do about that? Because we're not tearing up the roads and we're not able to address some of the impact of your ecological fitness. We need to compare your ecological footprint to the biological capacity of the area. How good is the place where you are getting your resources from? How good is it at restoring itself? So we talk about biocapacity, which is short for biological capacity. I changed the picture here, so if you look down, turn this into a graph. When we talk about your ecological footprint and whether you are degrading or maintaining the biological capacity of the region you live in, one of the things we have been able to calculate is at what point are the people on Earth overusing resources in general. In 1971, this is the year after the very first Earth Day, this footprint was first used, and it was found that people were using, so this blue line here, people were using slightly more resources than the world was providing. And so it was like 99% of what people were using was able to be replenished, but 1%, there was a little bit of overuse. This is an ecological deficit. This is how much more you are using than what you actually have available. And you can think about it like a deficit in your bank account. If you spend slightly more each month than you make, over time you're going to eat away at your savings, and ultimately your bank account is going to be in the negative. Now you're in trouble because you ran out of money. If we are in the negative, and that's what all of this red is, all the way to 2025 here, when the world is in the negative, that means we're using more resources than the world can sustain. Right now, Earth Overshoot Day, I think will actually have class. It's in April, which means the world runs out of resources in April, and everything we use from April to December is in excess of what the world is providing. We're eating up future generations' resources. Another way of looking at this same thing, so I haven't changed the words, but I've changed the picture a third time, is like, what is your ecological debt? Now, these are in darker colors here, red, purple, and black, are places where people are using way more resources than are available. Places in these bright green are places where people are using way fewer resources or are keeping their resources in line, their resource use in line with the biocapacity. I think some of these are also no data is available, so be aware. There's no people here. There's no people here. A lot of northern Canada, no people. It turns out if there's no people, they're not overusing resources. We're like right here. Like right here somewhere. Yeah. I think if we zoom in, we'll probably find we're a purple black dot. And what are we going to do about it? Another way of measuring our impact on the environment is the IPAT score. It's super simple. This is not math here we're looking at. This is just the things that influence your impact, that's the I, on the environment. If your environmental impact here, this letter I, is made up of the size of your population, so as a country or a region or a state, the affluence, meaning how well do people live and how many resources they consume. For us in the US, our affluence is high, our population is compared to the size of our planet, and our country, and the technology is very high, and technology use can be used to offset some of the population size or affluence costs, because some of those technologies can be really beneficial. The switch over to solar power for us has meant that we pull less energy that is being used from burning coal. That actually is a more efficient energy source, but then you have to build new infrastructure. So I'm going to end this video soon, but I want to talk about some numbers that you want to hold in the back of your head. I will not ask you on an exam to tell me these exact numbers, but the general idea of them, so something close. How many people live on Earth? I said it in passing, but it's about 8.2 billion people. There's a link down here that will work. There are slides available for you to follow along with. You can click on this link. I am pointing like you can't see that. If you click on this link, it'll take you to the counter for right today, and it should be around 8.2 billion people. People replace themselves right now at about a rate of 2.1, which means we're making slightly more people every year than the number of people who already exist. So our population is growing, but it's not growing very fast. 2.0 would be a replacement rate. That would mean our population would be holding steady, and there would always be 8.2 billion people. The amount of carbon dioxide released per person in the least developed country, this is not right here, we'll just ignore it, is 0.3 tons. What do you think the carbon dioxide released per person in the most developed country? Ignore that, it's not supposed to be least. Do you think it's bigger or less than 0.3 tons? And do you think it's like double, a little bit more than 0.3? Yeah, it's a lot. And this is a measure of energy use. It's a measure of fossil fuel use, pretty much. This is not like we breathe more than those people. We use a lot of things that give off carbon dioxide as a byproduct. We need today, and the book has a big sign in the middle of it, on the middle of chapter 1, that says we need about 1.7 Earths to sustain us at the rate we are using resources today. The book also talks about by 2025, that's last year, by 2025, their fear is that we might need up to 3 Earths to support us. We only have data up to 2023. So that's why they talk about 2025. I think that's a lot of Earths. How many Earths do we have? I asked this in my in-person class, and everyone holds still and thinks about it. This is like a kindergarten level question. How many planet Earths do we have? Yeah. And I think the problem is, it's not that people think we have more than one Earth. It's that number, and even this number from the most recent data are not the same. I will come back in video 2. I'm going to give you a break. I think these videos tend to get a little long if I splice them all together. So I'll come back. I'll restart part two. Part two is going to summarize the causes of environmental problems. We're going to compare and contrast a little bit more about ecological footprints. And then I want to introduce you to some of the peoples whose names are going to come up a lot. You probably know most of these people's names. And I'll see you in the next video. All right.